Today we're going to look at a couple of arithmetic properties. I know that the word looks like arithmetic. Arithmetic and arithmetic are spelled exactly the same way. English is weird. When you're using it to describe something, it's arithmetic. When you're adding and subtracting numbers together, you're doing arithmetic. They're both spelled exactly the same way. So, with these arithmetic properties, people who are really good with numbers do these almost as naturally as breathing. People who are good at math but they're just not nearly as good at being able to do things mentally. So let's take a look here. Juno is working on simplifying the expression 24 plus 3 plus negative 4 plus 7. And he said, I know. It must be equal to 30 because 20 plus 10 is 30. First of all, sometimes when the kids in our stories go, ooh, I know, sometimes they're wrong, sometimes they're right. Is Juno right? Is the value of the expression 30?
Yes.
Yeah. How could Juno have found 20 and 10 in this expression? Yes, ma'am.
So basically, he did like 24 plus parentheses negative 4. And
Uh-huh.
that equals 20. And then he added 7 and 3 equals 10. And then if you add 20 and 10, it equals 30.
Yeah, exactly. So what he has done is he's rearranged the numbers and combined the ones that he wanted to, right? Because when you combine 24 and negative 4, well, that's a nice number. That's 20. All right? So in doing this, Juno has used a couple of different properties. First of all, the commutative property of addition, and then also the associative property of addition. The commutative property lets him rearrange the order, putting the 24 and the negative 4 together, and the 3 and the 7. And then the associative property lets him group the numbers. So he grouped the 24 and the negative 4 together, and then the 3 and the 7. So here's what I want you to think about so that you can remember these two different properties. For commutative, that has the same root word as commute. Now, although many more people work from home now than they used to, most people have to drive to and from work, right? Yes?
Yes.
That's called their commute. They're moving from one place to another. Let's move from one place to another. And then the associative property comes from the root word to associate. So there's a lot of different things you can think about for this. For example, somebody's business may be called Smith and Associates, right? You ever seen anything like that? Okay. Who are the associates? Well, the people that Smith works with, right? It's that group. Who are your associates? Are your associates the people you hang out with, right? Or, if you want to go the psychological route, you can do word association. Like if I say tent, what do you think of? Don't think long.
Camping.
Okay? So you associate tent with camping. Okay? Because in your brain, those are under the same group. Okay? So associate is about grouping. So, a question, does the commutative property work for other operations? In other words, can multiplication, division, and subtraction be done in any order? Yes.
I know it. I think it might just work for addition and maybe multiplication.
So I've got an addition and a maybe multiplication. So Quentin, what do you think?
Multiplication.
I'm sorry.
Not maybe it multiplication.
Yeah, definitely multiplication. 4 times 5 and 5 times 4, same thing. So the commutative property only works for addition and multiplication. So it just works for those two. For subtraction, 7 minus 3 is not the same thing as 3 minus 7. By the way, if I do 7 minus 3, I get what? 4. And 3 minus 7,
-4.
I get the opposite because I did them in the opposite order. And for division, and this is actually, this comes up if you've got 8 divided by 2, what is that? 4. What about 2 divided by 8? That's 1/4. There's a certain type of problem we do, and I can't remember where it is right now, later in this year, where I have students in the past in this class who have told me things like 3/6 is equal to 2. And I'm like, no, 3/6 is definitely a half. Okay? And everyone's smiling kind of smugly at this point, but I swear it happens every year that there's a group of students who loses their mind on that. When we get to that, I'll try and point it out. All right, does the associative property work for other operations? Can we regroup multiplication? So let's do that. If I have 2 times 3 times 5, if I group the 2 and the 3, is that the same thing as 2 times 3 times 5? Yes. So it works for multiplication. What about division? What if we did 8 divided by 2 divided by 2? Is that the same thing as 8 divided by 2 divided by 2? No. So that's not true. What about subtraction? Let's do 12 minus 3 minus 6. If I group those first 3, is that the same thing as 12 minus 3 minus 6? No, it's not the same thing, is it? So again, the associative property only works for addition and multiplication. All right, let's take a look at this one. Consider some that use both addition and subtraction. So let's say I have 7 minus 2 plus 4. Everybody calculate that quickly. Don't say it, just calculate it quickly. Hopefully you got 9. So, does the grouping matter? Is 7 minus 2 as a group plus 4 the same as 7 minus the group, or we just say the quantity 2 plus 4? Is it? No.
It is time for all 11th graders to go to the gym to get their picture taken at this time. Teachers and any staff members can also make their way to the gym and get their picture taken at this time. Thank you.
Why does that matter? Because order of operations says that addition and subtraction are done in order from left to right. And then, does the order matter? Is 7 minus 2 plus 4 the same as 2 minus 7 plus 4? No. And I'm going to just put the same thing. Order of operations says you do it in order from left to right. By the way, some students mistakenly believe you do all the addition first and then you go back and do the subtraction. That's not true. Addition and subtraction are equally strong in terms of order of operation. They're both done together in order from left to right. Now Juno has another idea. Wait, he says, can't subtraction be written using addition? Since order doesn't matter when we add, can't we just rewrite the subtraction as addition so that we can use any order? So let's rewrite the following so that each one involves only addition. Then use the fact that the numbers are all being added and the order can be changed to find a way to simplify each expression efficiently. So on this one, this would be the same thing as 17 plus negative 4 plus negative 11 plus 15. What would be an efficient way to do this? Yes?
17 plus 15 minus plus negative 4 plus negative 11.
Okay. I'm going to do it slightly different than that. I'm going to do the 17 last because I don't want to keep track of it. So I'm going to say, okay, do 15 plus negative 4 plus negative 11 plus 17. Because what does this whole first part add up to? 0. All right, let's see if we can do something with this. That's kind of ugly looking. So this would be 2 plus negative 2 times 3 plus negative 4 plus negative 2 times negative 4? I would regroup that because I notice what do these middle ones add up to?
0.
Try again?
Sorry. No, those first 3.
These two, the middle
Oh,
two.
wait,
Yeah. So I'm going to put that in a group. Negative 2 times 3 plus negative 4. And I'll put the other two in a group. 2 plus negative 2 times negative 4. Because that's going to be a negative 10. And this is going to be a positive 10. So the whole thing adds out to 0. All right. So you don't have to do that to do problems, but it does make things easier. Same thing is true if you're adding up a group of numbers. If you can find some that add up to multiples of 10, that makes it easier to do in your head. So let's look at this next one. Maria and Jorge are trying to simplify the expression negative 4/3 times 1 2/5 times negative 3/4. Maria started by rewriting 1 2/5 as 7/5, and this is her work. So she has negative 4/3 times 7/5 times negative 3/4. Then she multiplied the 7/5 and the negative 3/4 and got negative 21/20. And then multiplied that times negative 4 and got positive 84/60, which is 1 24/60, or 1 2/5. Jorge had a different idea, and I must say it's a better idea. He multiplied the negative 4/3 times negative 3/4 first. When you multiply negative 4/3 times negative 3/4, what do you get?
0.
Oh, not 0. And you get 1. Be careful. Multiply those together, you get 1. And then you just have the 1 2/5. So doing this gives me 1. That's a lot less work, isn't it? So if you can find things that multiply together to be 1, that is another way to be more efficient. So he used the commutative property of multiplication. He rearranged the order. Why did he decide to multiply these two together first? Because that product is 1. So in a multiplication property, the factors can be grouped together in lots of different ways. Let's verify that these two are actually equivalent to one another. So if we multiply together here, this gives us 12/20 times negative 2 is negative 24/20. Dividing them both by 4 gives us negative 6/5, which is negative 1 1/5. Let's show that that's equivalent to this one. When I multiply 2/5 times negative 2, what do I get? If I I multiplied 2/5 times negative 2, what is that?
No. 3 times 2 is 12. Because this would.
Oh, no. Thank you. I don't know, but I think I was thinking what it was going to be after I multiplied it times the 2. Thank you very much. So those are both divisible by 4. So that's negative 3/5.
That's what I
Okay, thank you. All right, back to this. 2/5 times negative 2 is negative 4/5. Oh, no, no, no. Remember, this is 2 over what? Over 1. So that's negative 12/20, which is also negative 3/5. All right. Any questions? Okay. That's it for today's lesson.